Today's video is about magnetic effect of electric current. So what is magnetic effect of electric current? A current flowing through a conductor produces a magnetic field in the region surrounding the conductor. So surrounding the conductor you get a magnetic field. So magnetic field, so what are magnetic field lines? If you consider a bar magnet, so this is north pole and this is south pole. Magnetic field lines, so what are the properties? It starts from the north pole. So it starts from the north pole and it moves towards the south pole. So from the north it starts and moves towards the south. And internally inside the magnet, whereas inside the magnet it starts from the south and ends in the north. And the magnetic force of they never intersect each other. So the magnetic force of line, they never cross each other, never intersect each other, and they are stronger near the poles. So these are the properties of magnetic lines of force, and they are denser, that is it's more denser near the poles. It's stronger and denser near the poles. So the properties is given here. So these are the properties of magnetic field lines. Next we'll go for magnetic field around a straight conductor carrying current. So this is an experiment. So here you have to take a rectangular cardboard. So this is a cardboard. So you have to take a rectangular cardboard and you have to make a hole in the center, middle of the cardboard, and you have to insert a conductor. So this is a conductor, a metallic conductor, through a hole, and you have to connect it to a battery. So you're connecting this and you're connecting to a battery here. A plug is there, battery is here, and rheostat is there. So you're connecting this one. Then you have to sprinkle a little bit of iron filings on the cardboard. Then you have to switch on. So on passing current, what happens is you have to gently tap this cardboard. You have to tap gently. So what happens is you can see that the iron filings, they align themselves along the field lines in concentric pattern. So you'll get the lines. So these lines are nothing but, this shows that a straight conductor carrying current, a magnetic field exists around it. So this is an experiment which shows about magnetic field around a straight conductor carrying current. The explanation is given here. Then the next experiment is magnetic field around a circular conductor carrying current. So this is also an experiment. For this experiment, so you have to take a rectangular cardboard and you have to make two small holes around it. So you have to take a rectangular cardboard and two holes here, and you have to insert a conductor, that is a metallic conductor, and this comes below this cardboard, and you have to connect it to the plug and to a battery, and you have to switch on the battery here, and you have to sprinkle little bit iron filings on the cardboard, and to see to that the cardboard is perpendicular, it is 90 degree to the conductor. So for this metallic conductor and this cardboard should be at 90 degree. So on passing current, what happens is you can see concentric pattern, that is the iron filings align themselves in concentric pattern around on both the sides. Around this here you find here, and in the center you can see parallel lines. So this is an experiment to show magnetic field around a circular conductor carrying current. So the written part for this. So the written part for this is a continuation. Next it is a solenoid. So this is a diagram for solenoid. So what is a solenoid? A coil of many circular turns of insulated copper wire wrapped closely in a shape of a cylinder. This is called as a solenoid. So this is a copper wire, insulated copper wire. It is wound in a form of a coil, cylindrical coil, and these two ends are being connected to a battery. So this behaves like a magnet. So such coil thing you called as a solenoid. So you find the magnetic field north and south, you find the similar pattern. If you take a soft iron bar, suppose a soft iron, and just insert it in this circular coil, it behaves like an electromagnet. So a solenoid can be converted into an electromagnet on taking a soft iron core and just introducing into the circular coil.